Alright everybody, so we are going to compute ANOVA with SPSS. So a quick overview of ANOVA. What ANOVA is doing is it's looking or examining the relationship between group membership and some interval ratio dependent variable. So the independent variable is going to be some group with two or more, or some variable with two or more groups, and the dependent variable is going to be some outcome on an interval ratio scale. So a couple of examples might be something like, and these are research questions I would ask, something to the effect of, who has the fastest 40-yard sprint time? Basketball players, football players, or soccer players, right? And so in that case, the dependent variable would be 40-yard sprint times, and the independent variable would be sport, and then you would have your three sports: football, basketball, and soccer. So that's what ANOVA does, and so we'll run an example today, and hopefully that'll clarify some of that stuff a little bit. So first, actually, let me close my output so we have a clean output. Let me enumerate my professor's data. Okay, so let me just give you a quick overview of this data. So we have a data set here with a variety of variables. We're only going to be using a couple of variables, and that is the wrong data set. This is the data set I want. So we're only going to be using a couple of variables here. So we're going to be using an independent variable that's nominal. So look for a nominal over here. And we're going to be using a dependent variable that is interval ratio. So look for something that says scale over here. Right? And anytime you see scale, you know that's an interval ratio type of variable. You have to set this up in SPSS, by the way. So let's kind of go through our steps here real quick. So ANOVA, first we have to make our assumptions. And as per the usual, these are just the assumptions that we make. There's nothing we can do about these. In ANOVA, the two things we can do about these is know that we're using the right variables in the analysis. So to go over these real quick, the assumptions we make when running ANOVA is one, that there's independent random samples. And what that means is when the groups were selected, those groups were selected independently from each other and randomly, right? So we've got to make sure that's true. If you already have pre-existing data, you had no control over that. Second assumption here is level of measurement is interval ratio for the dependent variable. Again, just make sure you have the right type of variable in the analysis. Populations are normally distributed. This is another big assumption that we have no control over as researchers, unless we have access to the population data and we can gather that information, which we typically can't. And same thing with this other one here, population variances are equal. What that means is that the variances between those populations, so in the soccer player, football, basketball example, the variability within those groups is equal across those groups. Second step here, state the null and research hypotheses. So I'm interested in, and I'll type this out, so I always follow my null and research hypotheses after a research question. So my research question would be, so my research question would be something to the effect of, are there differences in professor ratings? And I could be more specific on rate my profs across rank, right? And so we have typical ranks in higher education. We have lectures, We have assistant professors, associate professors, and full professors. And full professors have been doing this much longer typically, whereas the others not quite as much, with the exception perhaps of lecturers. So lecturers are kind of in a weird space in academia. So my question, and I should say specifically in the US, so my research question here are, looking at Airbnb, or excuse me, not Airbnb, Rate My Professors, and looking at our data, I'm wondering if perhaps one of those groups have higher ratings than the other ones. The difference between ANOVA and t-tests is that you do not state direction in ANOVA. You state direction in t-tests, but you do not state direction in ANOVA. So we have no concerns about one-tailed or two-tailed tests or anything like that. Everything is just difference, right? So we're looking for differences across the groups. Step 3 here, select sampling distribution to establish a critical region. Sampling distribution here is the F distribution, and our it's just like the T distribution or the Z distribution. It's just a different type of distribution that can cooperate and work with multiple groups. Alpha, we typically set our alpha at 0.05. This is done by the researcher. It's setting our confidence levels. Then we have our degrees of freedom within and degrees of freedom between. This helps us find our F critical region. And the way we find the degrees of freedom within is N, which is our sample size, minus K, which is the number of groups we have in our independent variable. So that's our degrees of freedom within. So N minus K, sample size minus groups. And degrees of freedom between is K minus 1, so number of groups in our independent variable minus 1. So if we have 4 groups, our degrees of freedom within is going to be 3. And then we find our F critical by using both our degrees of freedom within and our degrees of freedom between with our book, along with our alpha level. Now we compute our test statistic. Now remember, even though SPSS might not explicitly tell us these things, it will always tell us whether or not our test statistic is beyond the critical region, right? And that helps us make our decision. So let's run that analysis real quick. So what I'm going to do is I can actually do this in here. So I'm going to go to Analyze. I'll take a second for you. Go down to Compare Means. Then go over to One-Way ANOVA. And this is what we'll be using. And so the difference here between SPSS and let's say something like Excel is that there's a lot of data manipulation that needs to be done in Excel in order to get the raw data in a form that can run ANOVA. It's really clunky. Excel's really clunky with ANOVA. SPSS is fantastic with it, and you'll see. So I'm going to click my button, and I'm going to clear all this out. You shouldn't have anything in yours unless you've been messing with this before. And so the one specific variable I'm interested in here is what are the ratings of your professor, right? So overall quality. And that ranges in Rate My Professors. So what students do is they go on Rate My Professors and they rate the professors on various characteristics. And so overall quality is one of those, and it ranges from 1 to 5, 5 being the best, or 5 being the highest. It's sort of a star rating. And then rank, I got rank here, and I have some data for tenure track faculty, assistant professors, associate professors, and full professors, and those are the full 4 categories. So what I want to do here is I want to click on this button that says Post Hoc. And if I have Tukey selected, what Post Hoc does is it does independent tests for each group, right? So it compares assistant professors to associate professors, then assistant professors to full professors, then to lecturers, and then it does the same thing for lecturers, does the same thing for associates, and so on. So it's essentially what it does is it runs a series of independent sample t-tests to compare those groups. Then I want options, and I always do descriptives just because descriptives give us the information that we need. So it gives us the descriptive information of each variable and each group. And then I click paste. And I click paste because it puts it down here. So I'm going to highlight that, and then I'm going to press this play button at the top. And here's our output. So here's our results. So let's take a look at what this means real quick. For some reason, SPSS is set to a lot of decimals. I'm not sure why. But see, you can see here, we can see our sample size. So we have 30 lectures, 12 senior lecturers, 3 assistant professors, and 4 tenured faculty. So I guess I truncated those, and so tenured faculty would be associate professors and full professors. Essentially anybody who's been teaching at the university for more than 6 or 7 years. So we have our mean here for each group. All right, so we have our mean. I just double-clicked on that. We have our mean for lectures, number of rankings, or not number of rankings, but level of ranking, senior lecturer, assistant professor, and tenured faculty. And just by looking at this, right, we can see that tenured faculty have higher ratings overall. But it's very subtle, right? It's not very much more than assistant professors, not very much more than senior lecturers, and not much more than lecturers. And then when we also take into consideration the standard deviation, that's another issue that would lead me to possibly conclude that this might not be a significant difference. But the ANOVA will tell us if that's the case. And so here's our model results, so the overall results of our test, right? And so what we want to look at here is these two numbers, and really this number here, right? And just to go over each of these, sums of square, we're not going to really report that or anything, so you don't really need to know much about that. But we have our between groups degrees of freedom, so we have, remember that formula, so we have 4 groups minus 1 gives us a degrees of freedom of 3. And then in this one, we have a sample size, or an N, of 67, and then minus 3 groups, and that gives us degrees of freedom within of 64. And then mean square we're not going to concern ourselves with. So what we want to know is this F statistic and the significance level. So in ANOVA, just like every other statistical test, if the significance is less than 0.05, we reject our null hypothesis and we accept our research hypothesis. So what this is telling me is that because this is not less than 0.05, in fact it's much greater than 0.05, we'll actually be accepting the null hypothesis in this case. So to interpret that, and I'll write that, is that there are no statistically significant differences in the average rating between lecturers, senior lecturers, assistant professors, and tenured faculty. All right. Now we can head down to our post hoc test. And what our post hoc tests do is, as I mentioned earlier, is essentially run a series of independent sample t-tests. That's sort of theoretically what's going on here. Statistically, it's not that easy, but it's about the same. So a run of independent samples t-tests, and so in this case, just to highlight this, comparing lecturers to senior lecturers, to assistant professors, to tenured faculty, then comparing senior lecturers, to assistants, to tenured faculty, so on and so forth, right? Then you have the mean difference, that's the difference between the two groups. So I, which is lecturer, minus J, which is senior lecturer. Standard error, we're not super concerned about, and significance level. So as you can see here, there's really what we're looking for is anything less than 0.05, and we find very, very little of that, right? So we'll come to the conclusion that, again, there are no differences between these groups. And this will give you the Tukey's output. You don't really need to worry about this too much. This is kind of repeating what we've seen above. So now that we know that, the two pieces of we need several pieces of information for our interpretation. So I'll be skipping back and forth between. Actually, you know what I'll do is I'll pop that over there, and I will pop this over here so we can see both. And let's do that. And let's do that. So let's make some interpretations here. So now we have a decision maker, right? So I would say reject the research hypothesis because, and this is not how you would formally write this out, but this just gives me a note, is not, I'll do less than 0.05. So the significance is not less than 0.05. So I would interpret this, and I would say something to the effect of, and actually it's a one-way ANOVA to be official. Whether were differences in so one-way ANOVA was conducted to examine whether there were differences in professor ratings on Rate My Professor across rank, right? And so again, I'm putting in the two variables here. The ratings is the dependent variable, and the rank is the independent variable. And I'm actually going to put those in parentheses so you can see them. I always put we because I collaborate a lot, so I'm used to writing we found. I rate that way too often. So instead you can write I found. Some social scientists will say speak in the third person. So say something like it was found, which I find very strange, so I write in the first person. So I say something to the effect of I found no significant differences across rank. And what you could do in this is what I would recommend is having the means and standard deviations in there. So I might say something like lecturer mean, and I'm just going to put M because SPSS doesn't allow notation. Mean 3.69, standard deviation 1.18, rounding up a little bit. Lecturer, senior lecturer would be mean of 3.65, the standard deviation of 0.73. Then I would do senior lecturer. Actually, we'll do that. What else? Assistant professor. So what I'm doing here is adding in the descriptive data from the analysis. So I'm adding the means and standard deviations of each group. Typically, it's fairly typical to do that, and mean and standard deviation is a very typical statistic to add to your groups in something like ANOVA. Or my standard deviation is 0.95, and To move backward to have a mean of 3.7273. If this were significant, I might be a little more descriptive about it and state exactly which, actually I don't want to say might, I would be more specific about it and state specifically which group was higher and which group was actually statistically significantly higher. So I would definitely do that if you had significance. We don't have significance here, so I'm not going to write that. So what I would say, for example, is a one-way ANOVA was conducted to examine whether there were differences in professor ratings on Rate My Professors across rank. I found no significant differences across rank, and then I added in the lecturer mean and standard deviation, senior lecturer mean and standard deviation, and so on. And then I would actually end it with F, and then we need to put the degrees of freedom, so I always put the degrees of freedom between, comma, degrees of freedom within for the F, and that equals 0.110, and I'm getting that data from here, right? And then the significance is, since we set our alpha level, we're going to just say P is greater than 0.05, and that's our little thing here. So that's how you run and interpret an ANOVA. I know it was fairly quick, but hopefully you have an idea here. So the two most important things: make sure you have some group for your independent variable, or some nominal grouping. Can be ordinal, but typically some nominal grouping. And your outcome variable, or your dependent variable, is some sort of interval ratio type of variable. Alright, so hope that was helpful.